Alright, Physics 133. For this week's video, we're going to be doing problem from chapter 32, problem 35. Alright, so in this problem, you have a capacitor of unknown capacitance, a resistor of 100 ohms, and you know that it discharges to 25% of its max charge in 2.5 milliseconds, which is 2.5 times 10 to the negative third seconds. So that's what we're given. What we're trying to find is the capacitance of the capacitor. Now this seems pretty complicated at first, but because of the equations that we're given, it's really just kind of a plug and chug kind of a problem. So we start with our discharge equation, which is charge equals the max charge times e to the negative t over rc. Now what are we given? We have our Q is 25% of Q max. So we have 0.25 times Q max equals, well, we don't know our Q max. That's we just don't know it, but it's okay because it's going to end up canceling. We'll see. Alright, so we have 0.25 Q max equals Q max times e to the negative t. Well, we know what t is. It's 2.5 times 10 to the negative third seconds divided by R times C. Well, R is 100 ohms. That's another thing that's given to us. And C is what we're trying to find, so we just leave C in there. So now it's just a matter of algebra to solve. You see these Q maxes? They cancel. So that's pretty easy. So you have 0.25 equals e to the something. Well, how do we solve a number equals e to the something? You take the natural log of both sides. So let's do that. The natural log of 0.25 equals the natural log of e to the negative 2.5 times 10 to the negative third seconds over 100 ohms times the capacitance. Well, the natural log of e to something is just that something. So you have the natural log of 0.25 equals e to the negative, sorry, not e to the negative. The natural log of e to the something is just that something. So you have natural log of 2.5 over here on the left equals negative 2.5 times 10 to the negative third over 100 c. So continuing our algebra, we want to multiply both sides by c and divide both sides by natural log of 0.25. That gives us c on the left side equals negative 2.5 times 10 to the negative third over 100. Notice we're to divide both sides by natural log of 0.25, so over 100 times natural log of 0.25. Plugging that into our calculator, we get that C equals 1.8 times 10 to the negative fifth farads. That's a completely fair answer. We're a little more used to looking at things in microfarads instead of just times 10 to the negative fifth scientific notation. So this also equals 18 microfarads. And that's your answer. Easy as that. It seems pretty intimidating at first, but really you just kind of plug it into the discharge equation and do some snazzy algebra, and you are all set. Hope that helps. See you guys tomorrow in class. Later.